This is a multiple-choice question testing my knowledge of the Sklearn datasets. Make_spd_matrix function in Python's scikit-learn library. I need to identify which statements about the function are true. I'm being asked to evaluate several statements about the make_spd_matrix function and determine which ones are correct. This will test my understanding of this function's properties and capabilities. This statement claims that the function creates matrices that are both symmetric, equal to their transpose, and positive definite, all eigenvalues are positive, and that I can control the size of the matrix. This statement asserts that the function always produces matrices with a condition number of 1. The condition number is a measure of how close a matrix is to being singular, non-invertible. A condition number of 1 indicates an ideally conditioned matrix, which is rarely achieved in practice. This statement says that using the _random_state parameter ensures that I get the same matrix each time I run the function with the same settings. This is because the parameter acts as a seed for the random number generator, controlling the randomness in the matrix creation. This statement claims the function can produce matrices containing only integers. I need to determine if that's a correct claim about the function's behavior. This line helps me understand that the question is about the make_spd_matrix function, which is from the Sklearn datasets module in scikit-learn library. SPD stands for symmetric positive definite. I'm assessing your understanding of the skikitlearnmatrix function. We'll look at several statements and decide if they're accurate. Let's see how well you know this function. This statement is correct. The makespdmatrix function's main job is to create matrices that are both symmetric, meaning they look the same when flipped across their diagonal, and positive definite, meaning all their eigenvalues are positive. You can also control the size of the matrix. This is incorrect. While the function aims for well-behaved matrices, a condition number of exactly 1 is not guaranteed. A condition number close to 1 is better, but 1 is a very specific outcome. That's right. The _randomstate parameter lets you set a seed for the random number generator. This means that if you use the same seed, you'll always get the same matrix. This is super useful for reproducing your experiments. Nope. By default, makespdmatrix uses floating point numbers, not integers, when making the matrices. I think this statement is true. The makespdmatrix function's whole point is to create these kinds of matrices, and you can control the size. Yep, that's what I just explained. Absolutely true. Setting the randomstate lets you get the same matrix every time you run the function. It's like setting a seed for your random number generator. This one is false. Makespdmatrix usually creates matrices with decimal numbers, not just whole numbers. I found this to be false. A condition number of 1 means a perfect matrix, and while makespdmatrix aims for well-behaved matrices, it doesn't guarantee that specific condition number. I'll help you understand the make_spd_matrix function from the scikit-learn library. It's a tool to create special types of matrices called symmetric, positive definite matrices. We'll explore what that means and how the function works. This is a multiple-choice quiz to test your knowledge of the make_spd_matrix function. Get ready to apply what you know. I'll guide you through each statement, helping you determine if it is correct or incorrect based on your understanding of the make_spd_matrix function. This statement is true. The make_spd_matrix function's core purpose is to generate these kinds of matrices, and you can specify the size. This is false. While the function aims for well-conditioned matrices, a condition number of exactly 1 is not guaranteed. Think of it like aiming for a bullseye. You might get close, but a perfect hit isn't guaranteed. This is absolutely correct. The _random_state parameter acts like a seed for the random number generator, allowing you to get the same matrix each time you use the same seed, ensuring reproducibility of results. Nope, this statement is false. The function generates matrices with floating point numbers by default. Integers are not the standard output. This section summarizes the multiple choice questions posed. Now let's see how you understand the material. I'm asking you to identify the correct statements about the sklearn function in the skitlearn library. This function creates special types of matrices, and we need to determine which properties these matrices always have. This statement is incorrect. While the makespdmatrix function aims to create well-behaved matrices, it doesn't guarantee a condition number of exactly 1. The condition number measures how close a matrix is to being singular, not invertible. A condition number of 1 indicates a perfectly conditioned matrix, which is rare. This statement is correct. The randomstate parameter acts like a seed for a random number generator. If you use the same randomstate value, the function will always produce the same matrix, making your results repeatable. This is very useful for testing and debugging. Incorrect. Makespdmatrix typically produces matrices with decimal numbers, floating point numbers, not just integers. It doesn't have an option to restrict the output to integers only. This is true. By definition, the makespdmatrix function's main job is creating symmetric, positive definite matrices. A symmetric matrix is identical to its transpose, a mirror image across the main diagonal. A positive definite matrix has positive eigenvalues which are the solutions to a characteristic equation associated with the matrix. You can specify how many features, or dimensions, your matrix should have when you use the function. This is a multiple choice question testing your understanding of the Sklearn datasets. Make_spd_matrix function in Python's scikit-learn library. I'll assess your knowledge of its capabilities and the properties of the matrices it produces. Let's get started. I'm asking you to identify all the true statements about this function from the given options. Think carefully about each statement before selecting your answers. Good luck. I'm providing you with some background information to help you answer the question about the make_spd_matrix function. Specifically, I am describing the function's purpose, which is generating symmetric, positive definite matrices. Understanding this fundamental point is essential for answering the question correctly. This statement is directly related to the core function of make_spd_matrix . A symmetric matrix is identical to its transpose, and a positive definite matrix possesses only positive eigenvalues. The function allows you to specify the dimension of the matrix. This statement claims a very specific property of the output matrix, a condition number of 1. I'm testing if you understand that while the function aims for well-conditioned matrices that aren't close to being singular, it doesn't guarantee a condition number of exactly 1. The _random_state parameter is crucial. It acts as a seed for the random number generator within the function. This ensures that when you use the same _random_state the function will produce the same output matrix each time. Reproducibility is essential in many data science applications. This statement tests your understanding of the data type of the output matrix. I'm checking to see if you know that make_spd_matrix primarily generates matrices using floating point numbers, not just integers. This section's not directly part of the question. It's there to set the stage, indicating that the question focuses on understanding inputs and outputs of a function. More specifically make_spd_matrix .